Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 1 in the SSRF module titled Basic SSRF Against a Local Server. Alright, before we continue with the video, I'd like to announce that this video is part of a course that I offer on my academy. Now you might be wondering, why would I buy a course that is made available for free on YouTube? Well, there are 4 reasons why you might want to do that. Number 1 is that you gain early access to recorded material. As soon as I record new videos, I make them available through my course right away. Whereas on YouTube, they'll only be released on a weekly schedule. Reason number 2 is that you gain access to a Discord channel where you can ask questions. The Discord channel is divided into topics that we cover in the course, and if you run into any issues, you get to ask questions about anything related to the course material. Reason number 3 is that you no longer have to deal with YouTube ads or sponsor messages. And last but not least, reason number 4 is you get to support me. Any revenue generated from this course will go back into maintaining the academy and creating more videos and courses that will be made available for free on my YouTube channel. So if you're interested in buying the course, make sure to check out the link in the description. And that is it. Let's go back to our video. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy, go down, select the learning path, go down, select server-side request forgery, go down one more time, and click on the first lab titled Basic SSRF Against the Local Server. Alright, let's get started. This lab has a stock check feature which fetches data from an internal system. To solve the lab, change the stock check URL to access the admin interface at http://localhost/admin and delete the user Carlos. Alright, so our vulnerable parameter or vulnerable feature is the stock check functionality, and the goal of the exercise is to change the stock check URL to access the admin interface and delete the user Carlos. So we're going to copy that right over here, paste it, hit enter, and let's click on view, toggle word wrap. Perfect. And then create an analysis section. Click on Access the Lab to access the exercise. This might take some time to render, so I'm going to open up Burp Suite in the meantime. I'll be using the Professional Edition just because it's faster. However, you don't need the Pro version of Burp in order to complete this exercise. And I won't be using features that are only available in the Pro version without letting you know first. Right, let's click Close, hit Next, start Burp. Make that a little bit smaller. Put that over here and click on the Proxy tab. Alright, so in Foxy Proxy, set your browser to send requests to Burp. And now when we click on View Details, it should be intercepted in Burp, and it is. Alright, perfect. Let's forward this and this one as well, and look for the stock check feature. If you go down, you see that there's a product, the description of the product, and then there's a check stock feature that allows you to check if this product is in stock. So let's click on that, and again, it should be intercepted in Burp, and it is. So what we're going to do is we're going to right click and send this to Repeater and work from Repeater from now on. Alright, going back to Burp, let's make this a little bit smaller. You could see over here that in the stock check functionality, there's a parameter called stock API that is sent, and it looks like it's a URL. Because you could see over here, there's an http://stock.welike2shop.net. So this is URL encoded. So what I'm going to do is Control-Shift-U to decode it and look at the URL. Alright, so it takes in a URL to the application and it's running on port 8080, and the path to the stock check feature is /product/stock and then /check, and then it takes in the product ID. So anytime you see a URL in the application, you definitely need to test for SSRF. So the first thing I'm going to do is click on send to see what a usual response looks like. And it tells me it's missing a parameter. That's probably because it's not URL encoded. So let's encode it again. Control U, hit send, and here we go. So a normal response is to get the number of items that are available in stock, which in this case is 388. So let's go back. The first thing that I will do is see if I could access the application itself. So I'm going to hit send. And it says missing parameter. Let's do Control U to URL encode it, hit send, and it still says missing parameter. So it's likely that you can't call this URL without providing the parameter value to the stock that you want to check. So the next thing that I usually do is check if there's an application running on localhost. Of course, if this is not vulnerable to SSRF, the request shouldn't be accepted. So let's try first localhost, hit send. And perfect. So we do get a response, which immediately tells me that this is vulnerable to SSRF. I'm going to click on render. This is a feature that is available both in the Pro version and the Community Edition. However, I've never gotten it to work in the Community Edition. So it might not be something that you could do if you're only working with the Community Edition. So I'm going to click on render and see. Let's go back. So we've clicked on render and let's see what appears to us. So over here, it looks like we're on the same application that we were on, except that in this scenario, we have something called an admin panel, which we didn't have before. Now, I don't have the source code to this application. However, what likely happened is that the same application is running on localhost, so locally on the server, and the application does not require you to log in order to access the admin panel, because it's assumed that if you can access the server, then you're already authenticated. Whereas in this scenario, you're coming from an external perspective. So in order to get to the admin page or any other account on the system, you have to click on My Account. And we might be still intercepting this in proxy, so let's set intercept to be off. Yep, so you have to click on My Account, enter your username and password, and then log in. However, because we're exploiting the SSRF vulnerability and there's a trust relationship between the application and the server it's running on, we're able to access the admin panel as if we're logged into the server itself. All right, so if we go to raw over here and we search for the word admin, you could see that it's running on the path /admin. So we're gonna add that to our request. So let's make some notes over here. So to access localhost, all we had to do is visit the URL, localhost, and then to access the admin interface, we looked at the source code and we saw that the path for the interface is /admin. So this should work because as we saw on localhost, the admin is already logged into the system and we don't need to authenticate. So if we click on raw and then hit send, we should see the admin interface. Again, I'm going to click on render and see what I get, and perfect. So the admin interface allows you to delete users, and in this case, these two users over here. And in order to delete the users, you gotta click on the delete button. Perfect. So we go back to raw and let's do a search on Carlos and see what the path is in order to delete the user Carlos. And the path is admin /delete username and Carlos. So let's make note of that. Delete Carlos, and let's copy that over here. All right. Again, in order to perform this attack, we have to go through the vulnerable parameter and perform another SSRF attack. So let's copy this, put it in here, and see if we successfully delete the Carlos user. All right, hit send, and we get a not found. So we might have made a mistake. And I know what we did. So this is And let's remove it from over here because we're going to use that for our script in a bit. And save it and hit send again. Okay, we get a 302, which is a really good sign. That means that the request passed through and it's getting redirected to another page. So let's follow redirection. Perfect. We get a 401 unauthorized. All right, and the reason we get a 401 unauthorized is because we're requesting the admin page from an external perspective versus from an internal perspective when we were exploiting it through the parameter that is vulnerable to SSRF. So in order to confirm that this has worked, we need to access the admin interface again. Let's go back and access the admin interface to see if it still allows us to delete the Carlos user. If it does, that means the Carlos user still exists in the database and that our attack failed. However, if it doesn't, that means our attack was successful. All right, hit send. And let's look for Carlos. There's 0 matches. That's a good sign. If we click on render, here we go. We only have 1 user to delete because we successfully deleted the Carlos user. Perfect. So if we go back to our exercise, we should see the sign, congratulations, you solved the lab. All right, so we successfully completed the exercise by manually exploiting an SSRF vulnerability in order to access the admin interface that was available on the application running locally on the server and delete the Carlos user. The next step that we're going to do is script the exercise. And if this is the first time you've come across my videos and are wondering why I script the exercises, it's so that you get more experience in scripting exploits in Python. I believe it's a necessary skill in order for you to become a professional pen tester, and so I script all the exercises in my videos. All right, as usual, the first thing we're going to do is import requests. Next, we're going to import sys and the URL lib3 library. We're also going to disable URL warnings if we don't have a valid certificate. So URL lib3.exceptions.insecure request warning. And I'm going to click on view, toggle word wrap so that everything shows on screen. Perfect. We're missing a curly bracket. All right, next I'm going to set my proxy's parameter. And what that does, it configures the proxy that I want to send all my requests to. The reason I do that is because in case the script doesn't work, I could intercept the request that the script is making in my proxy and debug why the script is not working. So it's 127.0.0.1, 8080, and HTTPS is the same, 127.0.0.1, 8080. That's what Burp Suite is running on. All right, and then we're going to say if name is equal to main, then call the main method, and let's write up our main method. All right, we're gonna say if the length of the command line parameters is not equal to 2, then print this message over here. The usage requirements, which is the name of the program, and the URL. And the name of the program would be the first parameter that you include in the command line. .argv 0. So I've given the user usage instructions. Next, I'm also going to give the user an example just so that it's completely clear. So we're going to say example. Again, the name of the program. And let's say the URL is www.example.com. And let's take in the name of the program. So argv 0. All right. And if you're running in this if scenario, that means you've ran the program incorrectly. And instead of the program giving you an error message, I want it to display a nice message that tells you how you should run the program. So last thing we're going to do is going to close the program because you ran it incorrectly. All right, so assuming you gave the program the correct number of arguments, we're going to take the URL that you entered in the command line and save it in a parameter called URL. So sys.argv1. And if that's not clear, what I'm trying to do over here is have a program that requires 1, you add Python 3, and then the name of the program, which could be lab01.py, and then it takes in a URL, which would be, in this case, www.example.com. And then from there, it performs the SSRF attack and deletes the Carlos user. Okay, so we're taking in the URL parameter, and then we're going to print deleting Carlos user. And then we're going to call on a function that we're going to create in a bit called delete user that takes in the URL. All right, that looks good. Let's save it and start working on the delete user function. Okay, it takes in the URL. And we need the path to the payload. So let's say that's called delete user URL SSRF payload. That's a really long variable name, but I want to be descriptive. And the payload is this over here. So that's how we delete a user. Let's copy it, put it in here. That looks good. Next, we need the check stock path, which is this one over here. Let's go back. Let's copy this. That's the page that contains the parameter that is vulnerable to SSRF, so we're going to copy it. I'm going to click send one more time, and it already errored out. All right, that's fine. We're just going to have to create a new instance of the lab. Okay, and then the parameters in the request are going to be stock API, because that's the only parameter that is available over here. And the value of the parameter is going to be this payload over here. So it would be delete user URL SSRF payload. And then the last thing that is left to do is to perform our request. So we're going to say R is equal to request dot post. And the reason it's a post request is because you could see over here the request that is originally being performed is a post request. Next, we're going to say the URL is the URL itself plus the check stock path. So what this is going to do is it's going to take the URL that you give the script as a command line argument, and then it's going to add the vulnerable path to it, which is /product/stock. Next, we need to add parameters to the request. So we're going to say data is equal to params. And what that's going to do is it's going to add the stock API parameter to the request, just like it's done over here. We're also going to set verify to be equal to false because I don't want to verify TLS certificates. And I'm going to set proxies to be equal to proxies so that the request is sent to burp. Okay, that looks good. Now what this should do once the request is run is it should delete the user Carlos. The next thing that I want to do is check if the user is actually deleted. So I'm going to say check if user was deleted. All right, so now we need a new variable called admin SSRF payload, and that takes in the URL for the admin interface, which we'll get from over here. Next, we're going to create another params variable, so let's say params2. And take in the parameters for the request, which in this case, the name of the parameter is stock API, and it takes in the admin SSRF payload as the value of the parameter. And then we need to perform the request. So let's say R is equal to request.post, and then it's URL plus check stock path, and data is equal to params2, verify is equal to false, and proxies is equal to proxies. All right, and then in the response of this request over here, I'm going to check if you can see the string user deleted successfully. If you can see it in the response, so r.text, then we're going to print successfully deleted Carlos user. And if you don't see it in the response, that means the exploit failed. So we're going to print exploit was unsuccessful. And let's save that. So this looks good. Let's try and run it and see if there's any errors that we need to fix. So terminal, new terminal. Let's clear this and let's remove this over here so that we have more space. If I can do that, I don't know. Oh, here we go. All right, perfect. All right, it's Python 3 SSRF lab 01.py, and then the URL of the application, and the application timed out, so we're going to have to close this one and generate a new instance of the lab. Okay, let's copy the URL, put it in here, and remove the last slash because we already added over here. So hit enter. Oh, perfect. So there is no errors, which is the first time for me. And we already get the congratulations, you solved the lab exercise, which means that it successfully worked. Now, if we go back to burp, since I sent all my requests to the proxy, we should be able to see the requests that were performed by the script. Okay, so if we look over here, it first performed a post request that deletes the Carlos user, and then the next thing it did is it performed the post request that checks the admin page, and then it checks for the string user deleted successfully in the page, and if it exists, that means that the Carlos user was deleted. All right, perfect. So we successfully completed the exercise by first manually exploiting the SSRF vulnerability in order to delete the Carlos user, and then we scripted the exploit in Python. In the next lab, we'll look at another instance of an SSRF vulnerability, which allows us to access a backend system. If you liked the video, hit the subscribe and share button so that the video reaches a wider audience. Also, make sure to check out my course if you're interested in seeing more videos like this one. Thank you and see you in the next video.